Alright, so today I want to talk about the case where you have a box sitting on top of an inclined plane with an angle of alpha. Now, this is rather counterintuitive because the horizontal force that's pulling it downward is Fg cosine alpha, and the vertical force that's anti-parallel to the normal force is Fg sine alpha. Now, normally, we ascribe vertical forces with a sine theta or sine alpha. And we ascribe horizontal forces with the cosine function. Now, what I'm going to do here is that I'm going to derive the forces of these vectors so that you won't be confused in the future. Right. So to start off, let's just draw the free body diagram for this object. Now, the force of gravity is not perpendicular to the surface of the inclined plane but points directly downward, whereas the normal force points perpendicular to the surface of the inclined plane. Alright. Now, if we draw this blue line over here that connects the box to the bottom of the inclined plane, and we note that this blue line is perpendicular to the surface of the inclined plane, this angle, right, is 90 minus alpha by the property that the sum of the interior angles of a triangle should be 180 degrees. So if this is also a right triangle, it stands to reason that this particular angle should be alpha. Now, if we draw this red line that's parallel to the surface of the inclined plane and perpendicular to the blue line that we just drew, okay, this is also 90 degrees, right? So this particular line will be Fg cosine alpha because it is adjacent to our angle alpha. Whereas this red line over here, okay, that's going to be Fg sine alpha because it is the opposite of our angle alpha. And that is how you derive this sort of counterintuitive thing with the forces of gravity on a box in an inclined plane with an angle alpha.